go, but we are recording now. And I will go to, well, actually, we'll be starting in 4.2 today. No, we won't. That's the first slide. However, we have the vocabulary from 4.1 to do. So we're going to be starting on page 267. I'm going to get set up for the for 4.2. So let me get this set up, and let me get, you can't see this, but this taskbar gets smack dab in the way. Oops, here comes Courtney. So let me see if I can get Courtney here. Yep, Courtney's here. All right, good class today. Look at this. I think we're up to 17 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17 students out of 18. No, we may have lost one. So, man, if it's not perfect attendance, it's awfully close. Way to go, team. Now, let me scoot this out of the way. You can't see what I'm doing, and I'm also going to move Matthew. You're in the way again, Matthew. Okay, I'm going to scoot you over. So, you got that as your screen. However, we're not going to start there yet. Let's start. Are there any questions before we begin? Okay. We will then start on, it's the very last thing in 4.1, the exercises. The first 6 exercises are vocabulary. Let's do those. This is on page 267. If you have your books, get them out so you can read them. If you don't, listen closely and see if you can answer. First question, vocabulary. 2 angles that have the same initial side and the same terminal side are blank. What's the word for them? Same initial side, same terminal side. They are called, anyone know? If you have your book open, scoot back to the first part of 4.1. This is a pretty long section, so I know it's been a while. This is on the bottom of page 260, the last bold word on the page, except for maybe the figure numbers. Same initial side, same terminal side, same terminal, co-terminal. Okay? Y'all are real good at this, aren't you? Okay. Number 2. 1 blank is the measure of the central angle that intercepts an arc length equal in size to the radius of the circle. What is that called? A measure of a central angle. We only have 2 ways to measure angles. This is one of them. And it's the measure that of a central angle that intercepts an arc length that is exactly equal to the radius. What is that measure? Equal to the radius. What is that measure called? This is at the top of page 261. Y'all are real good. Radian measure. Remember, that's what a radian is. It's a measure of an angle, either radian or degrees. It can't be degrees, it has to be radians, where it's the ratio of the arc length to the radius. And if they are equal, that defines 1 radian. Number 3. Off to a really good start here. 2 positive angles that have a sum of pi halves are blank angles. Okay, the first one's complementary, and 2 positive angles that have a sum of pi are supplementary angles. You're catching on really fast now. Okay, number 4. The angle measure that is equivalent to a rotation of 1/360th of a complete revolution about an angle's vertex is 1 1 360th of the way around the circle is 1 degree. Perfect, perfect, perfect. Number 5, 2 blanks in this one. The blank speed of a particle is the ratio of the arc length traveled to the elapsed time. Length per unit time, that would be the what speed? Linear speed. And the blank speed of a particle is the ratio of the change of the central angle to the elapsed time. Oh, Courtney must have left and come back. So here he is. Let me get him back in the room. Okay, what's that called? That's the angular velocity, or angular speed. Perfect. Number 6. The area A of a sector of a circle with radius r and central angle theta, where theta is measured in radians, is given by the formula blank. So give me that formula. Area. Perfect. 1/2 r squared theta. Perfect, perfect, perfect. Okay, I've already assigned all those homework exercises in 4.1, so we're ready to start 4.2. All right, and that's where we are now. Chapter 4 is still trigonometry. And yes, question? Okay. 4.2 is trigonometric functions, if I could talk, the unit circle. So we're going to start with the unit circle. When I started trig back in high school, which seems like decades ago, oh, it was decades ago, we always started with triangles and then later talked about the unit circle. Now just about all books start with the unit circle and then later talk about triangles. The next section is triangle trig, so we'll start with the unit circle today. Okay, here are our objectives. Identify a unit circle and describe its relationship to real numbers. Now that is a real nebulous objective. Describe its relationship to real numbers. I know what they're trying to say. That's a weird way to say it. Okay, number 2. Evaluate trigonometric functions using the unit circle. And that will be, yeah, a pretty handy little thing to do. And then 3rd, use the domain and period to evaluate the sine and cosine functions, and we'll use calculators to evaluate trig functions. Okay, all in this section. So let's start with the unit circle. Now what does the word unit mean to you? Any of you play the old card game called Uno? No? Probably too old for you. What you did when you got to your last card, you had to call out Uno. Uno. Okay? What did that mean? You had one card left. If you didn't call out Uno and you put it down, you didn't win, because you had to call out when you were at your one card left. Uno. Unit circle has something to do with the number 1, the unit 1, one single unit. What does it have to do with it? Well, and here they start a little bit. 2 historical perspectives of trigonometry incorporate different methods for introducing the trigonometric functions. One such perspective follows and is based on the unit circle. This is more recent history. The old history, originally trigonometry, had to do with triangles. That's where its name comes from, the measure of triangles. So this is the new kid on the block, and yet they always start first. Well, here's the unit circle right here. Okay, consider the unit circle given by this. Now what makes it a unit circle? Its radius is always 1. There's where the unit comes into play. Now they not just a circle of radius 1, but whose center is the origin. So this point out here is at 1, 0. This one up here at 0, 1. This one over here at -1, 0. Down here is 0, -1. Everywhere on this circle, this is true. x squared plus y squared is equal 1. That's the equation of a circle centered at the origin with radius 1. That's it. That's your unit circle. And we will be building our trig functions on that unit circle. And for many times in this course, you will be drawing unit circles. Later we'll draw circles that are not radius 1 because they're convenient too sometimes. And later we'll be doing triangles. And we'll see how all of them fit together. Imagine wrapping the real number line. Okay, think of the y-axis as a real number line. X-axis would also be the real number line. But let's take the y-axis. But we're going to take it and copy it over here. So here is 1/4, 1/2, 3/4, and 1. See, there's 1. Unit circle 1. There's 1. Okay? Okay, we're going to take that straight line and wrap it around the arc length. So 1/4 goes here, 1/2 goes here, 3/4 go here, and 1 unit goes here. Okay, guess what that radian is? I'm sorry, that angle is. Ew, I gave the answer away. That's 1 radian because the arc length is exactly 1, which is exactly the radius of the circle. Okay, now it can be wrapped anywhere. Okay, but that's a positive y-axis, but moved over here, wrapped around the thing. You can make this longer and wrap it all the way around to here or here or here, anywhere you want it to. That's going to define some angle theta. The one we've drawn here, if that is indeed 1, which I think it is, and that's 1 there, then this has to be theta is 1 radian. Okay, we'll get to that later. If, though, we took the negative y-axis and projected it over here, that's -1/4, -1/2, -3/4, -1, wrapped it around the unit circle this way, then the arc length here would be a -1. The radius is a 1, so that would be a theta of -1 radian, or whatever this demarcation is. If this had been longer and you wrapped it over here, then it would have been something over there, maybe 2.3 radians, -2.3 radians. Why? The angle is going clockwise. Up here, positive, because you're wrapping the positive y-axis around there and you're getting positive numbers. Okay, that's what the unit circle is. That's how it's related to the angle. In radians is the length of that wrapped real number line wrapped around the circumference of the circle. Okay. Now, as the real number line wraps around the unit circle, each real number t that you measure on that line corresponds to some point xy on the circle. Okay, if this t right here, this corresponds to this x and that y, right? This t up here corresponds to this x and to that y. Okay, so every one of these represents an xy point on the unit circle. And what is true about every xy point on the unit circle? This is true. X squared plus y squared equal 1, because every point on the unit circle satisfies that equation for whatever its coordinates are. If the x is over here, it's a -x over here, squared plus this y squared, that's going to equal 1. Okay? Going to happen every time. Okay. For example, the real number 0 corresponds to the point at 1, 0, because you haven't wrapped it all. You're right there you're right here. You haven't gone. You wrap 0 units around, so this point right here represents theta equals 0. Okay? Now, moreover, because the unit circle has a circumference of 2 pi, right? 2 pi r, but r is 1, unit circle. The real number 2 pi also corresponds to the point 10. Okay, because what if you went from here all the way here? That would be 1, 2, 3, pi, 4, 5, 6, 6.28 would be 2 pi. That would also correspond to this number, this point, 10. Also 4 pi, 6 pi, 8 pi, negative 2 pi would be there, negative 4 pi would be there, negative 6 pi would be there, all the even pi's, positive or negative, would be there. Okay? They all correspond to that 1.10, and 1 squared plus 0 squared is indeed 1. In general, every real number t corresponds to a central angle in standard position whose radian measure, not angular degree measure, radian measure, is equal to t. Okay? Now, notice they weren't calling this a length anymore. We were calling it arc length. They're not referring to it as a length, they're just referring to it as a real number. Well, radian, remember, is a ratio of arc length to radius, which has no units either, so that's just a real number. So when they're talking about the real number, they mean this value t. And that's what they meant back here. Sorry to regress, but let's regress right here, and its relationship to real numbers. These are the real numbers we're talking about. That wrapping of the, you might call it the y-axis around the unit circle, but not giving them any dimension, just the real number that represent it. That's the real numbers they're referring to. Just say, any real number. Well, yeah, it is, but they're talking about these specific real numbers. Okay? So, with that interpretation of t, the arc length formula, S is equal to r theta, when r is always 1, indicates that the arc length, but that's a length measure, is the same measure as the angle in radians. Okay, and we already talked about this. It's the directional length of the arc intercepted by the angle theta. Okay, theta is given in radians, which remember are dimensionless quantities. S is given in some sort of length measurement. You know, inches, yards, meters, furlongs, miles, whatever, centimeters, millimeters, whatever length that the radius is, the same length as that. This, however, is a dimensionless quantity. But because r is equal to 1, same unit as this, then the numerical value for S is the same as the numerical value for R, and that's that numerical value for theta. That numerical value is what they're calling the real number t. Okay. Now, we're on page 271, top of the page, the trigonometric functions. Okay. From the preceding discussion, it follows that the coordinates of x and y, remember every xy point on that unit circle, any point there on that unit circle, xy, that the coordinates x and y are two functions of, well, the coordinates x and y are two functions of the real value t. X is a function of t, y is a function of t. You can use those coordinates to define these 6 trigonometric functions of t. Here are our 6 trig functions. We'll use these throughout the course. Okay? Sine, I don't like to call them this way. Cosine, tangent, cotangent, secant, and cosecant. Now there's a reason they did them in this order. I like the order I said. It doesn't matter which order. Now they have abbreviations. All but one of them, the abbreviation is the first 3 letters. The abbreviation for sine is SIN. It's pronounced sine, not sin. Abbreviation for cosine is COS. Not pronounced cos, but cosine. Okay? Tangent is the first 3 letters tan, We don't say well, sometimes we do, but it's tangent. Okay, that stands for tangent. Cotangent, first three letters, C-O-T. We don't call it cot, we call it cotangent. Secant, first three letters, S-E-C. We don't call it southeast circumference. No, we call it S-E-C, secant. Okay? And then the one you can't do is cosecant. You can't use the first three letters because you already use those first three letters for cosine. So here we use the first three consonants, C, S, C. There is your cosecant, CSC. All the others are the first three letters. This is the first three consonants, cosecant. Now, those are just names right now, but we'll learn what they are. Here are the definitions, and this is on the top of page 271, of those 6 trigonometric functions on the unit circle. Now, this to me is what makes teaching the unit circle first seems to me to cause students to make errors because they remember these formulas and then try to apply it to angles. I sort of wish they didn't do that, okay? If they should give the relationship first and then you see why these are true, okay? I'll explain what I'm talking about in a minute. So let t be the real number, x and y be the coordinates of a point on the unit circle. Remember, they're always points on the unit circle corresponding to that t. Okay? The sine of this real number t, which remember is also your angle theta in radians, but they're calling it t now. The sine of t is the y value, period. Now, in reality, it's y over the hypotenuse. What is the hypotenuse? What's the radius of the unit circle? 1. So y over 1 is just y. But remember, sine of an angle t in radians is not always y. That's only true on the unit circle. Cosine of t is x. Okay? So here's how I think of it. The sine of t is the adjacent, is the opposite side. That's the y value. The cosine is the adjacent side. That's the x value of that angle, always measured from your horizontal positive axis. The angle's up here. The y value is the sine. The x value is the cosine. That's all it's saying. What then is tangent of t? It's defined to be, and I wish they went on and told you this, it's sine over cosine, y over x. Now, here we have a problem, Houston. You have x in the denominator. Well, x can't ever equal 0. Well, on the unit circle, x can equal 0. Look at that. X is equal to 0 when you're up here and also when you're down here, because your x value is 0 then, right? Let's go back one more slide. Right here, x is 0 here and x is 0 down here. So therefore, the tangent function is not defined at, and this angle here happens to be pi halves, and this one happens to be 3 halves pi or negative pi halves, or any 2 pi multiple added to that. Okay? So tangent is not defined everywhere on the unit circle. Sine and cosine is. Tangent does not have a value at pi halves or 3 halves pi. Just remember that. X cannot be 0 when you're talking about a tangent. Okay. Now, I like to go down here to cotangent. Cotangent is just a reciprocal of tangent. That is cosine over sine. That would be x over y. But now the y's can't be 0 because you can never divide by 0. Well, where is y equals 0? Right here. At 0 and at pi. Angle 0 and pi. I think they should, well, they didn't show them here. Okay. 0 and pi. So cotangent is not defined at t or theta equals 0 or t or theta equal pi. That would would be this angle right here. Not defined there on the unit circle, or anywhere really. Now, moving along, secant t. Remember I said cosine t is really the adjacent side over the hypotenuse, which is 1 for the unit circle always. Well then, secant t is the reciprocal of cosine. So you see tangent, cotangent is reciprocal of tangent, secant is reciprocal of cosine. And that would then be 1 over x. This is x over 1. This would be 1 over x. But then again, x can't be 0, just like it couldn't here. So secant and tangent, you'll find later, have a very special relationship. Even though they're not really connected in any other way, except the fact they're disconnected at the same place. They can't be defined when theta equal or t equal pi halves or 3 halves pi. And then cosecant, of course, is reciprocal of tangent, cotangent reciprocal of tangent, secant reciprocal of cosine, and cosecant is reciprocal of sine, so it's 1 over y. But then again, y can't be 0 because it's in the denominator, so t equals 0 and t equal pi. Cosecant, just like cotangent, not defined. Those are your definitions of your trig functions on the unit circle. Remember this. This does not pertain if you're talking general triangles or any other circle other than the unit circle. These only work for the unit circle. If you had put in here over 1 and over 1, and then call that 1 the radius, which of course it is on a unit circle, then you have your exact definitions, okay? But they start this way, which I find just a little bit confusing to students sometimes. I grade that on the first test and find a few students will miss that because they use this formula here when you're not on the unit circle. This only works when you're on the unit circle. In the definitions of trigonometric functions, note that the tangent and secant are not defined at x equals 0. Yeah, we saw that. For instance, because t equal pi halves, that corresponds to 0, 1. It follows that the tangent of pi halves and secant of pi halves undefined. They do not exist at that value. Similarly, cotangent and cosecant not defined when y is equal to 0, which would be at t equals 0 or t equal pi. That corresponds to the point 1, 0, cotangent 0, cosecant 0, undefined. They do not exist at the t equals 0 or t equal pi, either one. Now, remember those favorite angles we had? They don't list them all here, they just list a few of them. This is when you divide that unit circle into 8 equal arcs. Okay, in other words, all the way around is 2 pi, of course. Halfway around, that's half, is pi. A quarter way around is pi halves, and a half of that would be pi fourths. So here's 0, pi fourths, pi halves, 3/4 pi, pi, 5/4 pi, 3 halves pi, 7/4 pi, and then 2 pi. Those are these angles here. Now, they give you the points at which they are. Later, they'll have you calculate this. Let's go on and calculate it now. Now, notice at pi fourths, you're exactly halfway between 0 and pi halves, right? Halfway between there, this line right here, if you didn't have the unit circle here, you would call that the identity function, because y is equal to x, right? So let's write that down. Right here, on this line, y is equal to x. Because there, if you go over, a third of a unit on x, you'll be a third of the unit on y. Halfway on x, you'll be halfway on y. 3/4, you'll be 3/4. Y is equal to x. But we also know, because this is a unit circle, that x squared plus y squared is equal to what? 1. It's a unit circle. But this is saying that y is equal to x. So let's, instead of y, put x. So then you have x squared plus x squared, right? Because y is equal to x, is equal to 1. Well, this means that 2x squared is equal to 1. Let's divide both sides by 2. And that gives you x squared is equal to 1/2. Right? But what else that tells you is that x is then either equal to, we really should say plus or minus, but we're going to stay in the first quadrant, so we're only going to use plus, the square root of 1, which is 1, over the square root of 2. Okay? But sometimes they don't like to write radicals in the denominator, so rationalize the denominator by multiplying numerator and denominator by square root of 2. Now why do we do that? Because square root of 2 over square root of 2 is 1. It's just, you're multiplying by 1, doesn't change the value, but what this produces is, let me come up here, I'll run out of room at the bottom, x is equal to the square root of 2 over 2, right? 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. Let me make sure nobody else came in. I think that was just popping up because I got too close to it downstairs. Yeah, okay. Now, if x is equal to root 2 over 2 and y is equal to x, then y is equal to root 2 over 2. So that's where you get your points, root 2 over 2, root 2 over 2. That's it. Now, over in this quadrant, you just go the same distance to the left as you went to the right here, so that'd be negative root 2 over 2, but you're the same distance up here that you went up here, so that's root 2 over 2. Down here, you're still on that line, so you're at negative root 2 over 2, negative root 2 over 2, because y is equal to x along that line. That's the identity function. So it's just the opposite. Over here, of course, your x is positive, root 2 over 2, same value as here, and this is the same value as that, negative root 2 over 2. So there you have all 4 of those points, plus the 4 that we knew to begin with, 1, 0, 0, 1, negative 1, 0. So now we know 8 points by heart on the unit circle. These are your friends. Get used to them. Get to know them. Okay? Any questions on that? And these correspond to these angles. This is pi fourths, pi halves, 3/4 pi, pi. You know, these are these angles right here, or real numbers, t, right there. So guess what? We can write it down. Sine of pi fourths is the y value, root 2 over 2. Cosine of pi fourths is root 2 over 2. Tangent of pi fourths is root 2 over 2 over root 2 over 2, which is 1. Okay? Cotangent of pi fourths is root 2 over 2 over root 2 over 2, which is still 1. Okay? So for every value here, all you have to do is read the y, read the x, and do the relationship. Secant would be 1 over x. So it's 1 over, well, if you remember, x is 1 over root 2, so 1 over that would be root 2. So we know for these 8 angles, we know all 6 trig functions, just like that. Okay? Now, they're going to do something else here. Let's divide the unit circle into 12 equal pieces. Okay? Now, again, all the way around is 2 pi, right? Halfway around is pi, and half of that is pi halves. Now, that is 1/4 of the circle. And if we were doing 12 equal pieces, we'll split that 1/4 into thirds. So 1/3 of pi halves would be pi sixths. 2/3 of pi halves would be pi thirds, and then this is pi halves. So each one of these represents a sixth of a pi. Okay, because all the way around here is 1 pi, you have 6 equal pieces. So this is 1/6 pi, 2/6 pi, which is pi thirds, 3/6 pi, which is pi halves, 4/6 pi, which is 2/3 pi, 5/6 pi, and pi. So there's pi 6, pi thirds, pi halves, 2/3 pi, 5/6 pi, and pi. Then this would be 7/6 pi, 8/6 pi would be 4/3 pi, 9/6 pi would be 3/2 pi, 10/6 pi would be 5/3 pi, and 11/6 pi would be 11/6 pi, and 12/6 pi would be 2 pi. So here are those real numbers. I think of them as angles. They call them real numbers t, the t values, for splitting that into 12 equal pieces. Well, they've identified some values here without telling you how they got them. Let me show you how they got them. Okay, and here's what we're going to do. This requires you to know one little piece of information about triangles. Okay, I just told you this was pi 6. Okay, right there is pi 6. So this would be pi halves. Pi thirds. 2/6 pi is pi thirds. I went half down and half up. Okay, now there's a reason I did that. If this is 2/6 pi, or pi thirds, now here's a piece of information you need to know. What is the sum of all the angles of a triangle? Anyone know that? If you add the 3 angles in a triangle together, what do you get? Say again. 180 degrees, which is how many radians? Pi radians. Okay, and this is 1/3 of a pi right here. We just said that. That's 1/3 of a pi. Now, if you were to extend a straight line, I don't draw straight lines too well down here, doesn't it make sense to you that this angle and this angle have to be the same? Because this is the same distance above here as that's below there, and this is a perpendicular line to both of them, to this line. So these two angles at least look like they've got to be the same, right? So let's just call these angles theta. That's theta, and this one theta. And what we just said, this angle right here was pi thirds. What we just said was that the sum of 3 angles of a triangle, this triangle included, equals pi. So what we have is 2 theta plus pi thirds is equal to pi. You buy that? Now, because I don't like fractions, let's multiply everything by 3. That would be 6 theta plus pi is equal to 3 pi. Would you buy that? Well, let's subtract a pi from both sides here. And this gives you 6 theta, because these two add to 0, is equal to 2 pi. Then let's divide both sides by 6. And that gives you theta is equal to pi thirds. Wait a minute. These two angles are exactly pi thirds as well. So this is what we call an equilateral triangle. That's pi thirds, that's pi thirds, and pi thirds. Okay? Now, if it's equal angular, which we just proved it was, that means it's also equilateral. The lengths are the same. So this length right here we know is 1, because that's the radius of a circle. This length right here we know is 1. That's the radius of a circle. Well, if they're all equal angles, that means this length right here is also 1. But it's the total length is 1, so that means up here this would be 1/2, and down here this would be minus 1/2. So we know the y value of, now go back to what we had. This first angle here is pi 6. This one right here. Remember, that was the pi 6. Okay? Just this angle right here is pi 6. So we have that for t equal pi 6, y is equal to 1/2. We know that. But we also know that x squared plus y squared is equal to unit circle 1. If this y is 1/2, which we just found out it was, that means x squared plus 1/2 squared is 1/4 is equal to 4/4. Isn't that 1? So subtract 1/4 from both sides, you get x squared is equal to 3/4. Is this okay? Take a square root of both sides, but we're only going to take the positive one because we're going to talk with this one up here. So that would be x is equal to the square root of 3 over square root of 4 is 2. That's what your x value is. Square root of 3 over 2. Hey, we got that. Okay? Now, if you go to this one right here, this angle right here, this has to be pi thirds again, right? Well, if this angle right here is pi thirds, that means this one is pi 6 because they have to add to be their complementary angle. They add to be pi halves. So if this is pi thirds, that's pi 6. Then this has to be 1/2 right here. Just like the y value was 1/2 here, that means the x value is 1/2 here. So this value, the x is 1/2, making the y root 3 over 2. And this one we already knew was 0, 1. Then this one's exactly opposite from there, so it's a minus 1/2 root 3 over 2. This one's exactly opposite here, minus root 3 over 2, 1/2. This one's, of course, minus 1, 0, opposite of this one. This one down here is minus root 3 over 2, same x value, and minus 1/2 down here. This is minus 1/2 for x, and minus root 3 over 2 for y, exactly the opposite y value, same x value is there. This again is 0, minus 1 here. Here we're back at 1/2 for here, and minus root 3 over 2 down here, and then here we're at root 3 over 2 for x, minus 1/2 for y. That's where we started. Hey, we know for these angles here, for these real numbers here, these 12 real numbers here, we know every x point, xy, on that. So therefore we know every trig function. Pick one, like right over here, this one right here. This would be 5, 6 pi. That would be this one right here, 5, 6 pi. The sine of that is 1/2. That's the y value. The cosine of that is negative 3/2. The tangent of that is this over that, which would be a negative 1 over root 3, which you could call it root 3 over 3. Okay, the cotangent of that would be reverse of that. That would just be a reciprocal of that, negative root 3. The secant, you can go on and name every one of them. The cosecant of this is, reciprocal of this is 2. Cosecant, we know every trig function, all 6 trig functions for all 12 of those real numbers. When you combine that with all, now some of these were the same. This was the same, that was the same, and that was the same, but you had 6 more here, so that makes 18. Already, right off the top, you know every trig function for those 18 real numbers. That's why they become your favorite of all times, okay? Because you know them, or you will know them before this is over with, Okay, now to verify the points, now we're going to do exactly what we did. To verify the points on the unit circle in figure 417, that was the one in pi quarters, quarter pies. Note that this also lies on the line y is equal x. We've already done this. So substituting y for x in the equation, we did that. We came up with that. We came up with that, and we came up with this. We didn't do plus or minus. We stayed up here, but plus or minus meant it was either up here or down there. Okay, plus or minus root 2 over 2. Okay, that was your x. But because the y's are the same, they're plus or minus root 2 over 2 here and here as well. So yeah, because the point that we're talking about was in the first quadrant, we used the positive root 2 over 2, and because x was equal to y, it's also root 2 over 2. We went through that. We've done it. Been there, done that, bought a t-shirt. Okay. You can use similar reasoning, only they don't, okay, to verify the rest of the points. We've already done that in figure 418. This is the one we just did. Using the xy coordinates, that you can evaluate the trigonometric functions for those, what they call the common t values. And I'll go over those in just a minute. But remember, these were all halves and root 3 over 2, except for your coordinate points. Okay, and then plus or minus. Everything else you just figure out with plus or minus. Okay, we did it. They didn't. We did. So here we have, evaluate the 6 trigonometric functions for each of these real numbers. So t is equal to pi 6. So what we want to do is the sine of pi 6. We want to do the cosine of pi 6. We want to do the tangent of pi 6. We want to do the cotangent of pi 6. We want to do the secant of pi 6. And we want to find the cosecant of pi 6. Now, to do that, what we do is figure out the xy point of pi 6. Now, we just did it, and hopefully you can remember it. The xy point for t equal pi 6, this corresponds to this point right here. If you remember, the x value was root 3 over 2, the y value was 1/2. Do you recall that? Go back and look. There it is. Pi 6 is right here. It's root 3 over 2, 1/2. There's the ordered pair that corresponds to that. So from that, you've got it knocked. Remember what sine is? Sine is always the y value, 1/2. Cosine is the x value, root 3 over 2. Tangent is the ratio of that. That's why I write them like this. Just imagine putting a ratio here, wiping out the 2's, and it's 1 over root 3, which we can also call root 3 over 3. Okay? What's cotangent? I like to come across here now. And remember, we call that 1 over root 3. The cotangent is reciprocal of tangent, so that is root 3 over 1. Okay? This is a reciprocal of that, so this would be 2 over root 3. Just reciprocate that. Reverse the order here. 2 over root 3 would also be 2 root 3 over 3 if you multiply numerator and denominator by root 3. And then this one is real easy. It's reciprocal of sine 2. That's it. 1 over y, which is 1 over 1/2, which is 2. Can it get much easier than that? Now, sure, I know y'all aren't as familiar with them as I am, but get familiar with them. Get to know them. They're your friends. They'll help you out big time. Okay? So basically, the first thing we do, figure out where you are in the unit circle. There is your xy point. Once you figure that out, then filling in the blank. That's all you do. Okay, now I don't know how to erase this. I wish I did. Okay, let's go to the whiteboard and do the same thing here. Okay, so let me go to the whiteboard and we'll do the next. Okay, I forgot to bring my I've got some water here. I've been talking for basically non-stop since 8:30 almost. So okay, we're example 1, we're the B part. So let's get the whiteboard up here. And now I've still got to do a little housekeeping here. You can't see this, but I have a toolbar that's smack dab in the way, so I'm going to move it out of the way. And then I'm going to take my whiteboard. You just see white. I have just a portion of my screen is white, so I have to move it to the left and up as far as I can to give me the maximum white space. So now we're interested in T is equal to pi fourths. 5/4. So here's what the B part is. T is equal to 5 pi over 4. 5/4 pi. Okay. Now, I don't draw unit circles very well. I'm going to see if this is going to help me any. I'm going to try it. Yuck! I don't know if you can see my fighting with this thing. But let me try to draw a circle here. Would you say that's close enough to a circle? Let's guess it is. Alright, now I'm going to draw my axes. Okay. Let's just imagine that's vertical. It's not, but let's pretend it is. And let's just imagine this one's fairly close to being horizontal. It's really not, but let's just say it is. Okay, that's my best guess of the unit circle. Okay, now where are we when we're at 1/4 pi? 5/4 pi. Yuck! There it went and erased my horizontal axis. Okay, still not very horizontal. Okay. Alright, now if you recall, this is 1/4 pi, 2/4 pi, which is half pi, 3/4 pi, 4/4 pi, which is pi. 5/4 pi would be right, stupid thing, right down here, somewhere right in there. This would be 5/4 pi. This is T is equal to 5 pi over 4. That would be this angle right here. That real number right there. Now, we've got to remember what our coordinates are. For the 1/4 pi's, remember they're all √2's over 2. Okay, except you got to get the signs right. Up here they're both positive, here they're plus minus, here they're minus minus. So as soon as you identify this point here, you can write down every one of the trig functions. Sine of 5/4 pi is the y value, minus √2 over 2. Cosine of 5/4 pi. See, the hard part, and it's not hard, is just finding what the coordinates are. Once you know those, you can write them down. Cosine is the x-coordinate, minus √2 over 2. Tangent of 5/4 pi is the ratio of these two. Well, guess what? That's 1. They're the same. There's a tangent. Well, guess what? The cotangent of 5/4 pi is the reciprocal of this, which is 1. 1 is 1 over 1, so cotangent would be 1 over 1. Just the other one. Okay. This one, the secant of 5/4 pi, is the reciprocal of cosine. Now remember, the other way of writing cosine would have been minus 1 over root 2, but we rationalized to get this, so this just becomes minus root 2. That's it. And guess what? Because the cosecant of 5/4 pi would be, reciprocal of that is the same thing, minus root 2. Okay, there we have it. Done. The hard part, figuring out where you are, Waldo, on the unit circle, and figuring out your coordinates. Once you have the coordinates, plug them in, plug them in. Sine is the y coordinate, cosine is the x coordinate, tangent is the ratio of those two, cotangent is reciprocal of that one, secant is reciprocal of that one, and cosecant is reciprocal of that one. That's it. That is it. Okay? Now, that was the B part. Let's do the C part. Now I'm going to keep as much of my drawing as I can because I'm lazy. It was hard enough for me to draw. Excuse me. Sorry, I didn't catch that in time. I blew your eardrums out, didn't I? Sorry about that. I would say send the ENT bill to the school, but they won't pay it. So, all right. Okay, next we're doing is just pi. Okay, so let's see if I can. I'm being very lazy here. Boy, does this feel lazy. Good and lazy. All right. Who doesn't like magic pens? Okay. This time we're doing t is equal to pi. That's what I have up here. Well, where in the world does t equal pi? Remember, all the way around the circle is 2 pi, so halfway around is pi. Here's t is equal to pi right there. That's the angle or the real number t equal pi. Well, what's your coordinates? Yes, what you got?
2-minute warning.
2-minute warning. Oh my goodness, he's been watching too much football, hasn't he? That's only for halftime. No, I'm just kidding. Okay, no, let's get it done. Okay, what's the coordinate point right here? This point right here? Easy, easy. -1, 0, right? And from that point, you can write in sine of pi is the y value, 0. Cosine is the x value, -1. Tangent is the ratio of those two. That would be 0. Uh-oh! Cotangent reciprocal of 0, you can't do it. This is undefined. Okay? Secant is reciprocal of cosine, which of course is also -1. But cosecant is, can't do reciprocal of 0, so this is undefined. So you see I got it done in 2 minutes, didn't I? All right. Do you see how that works? Okay. I didn't check my work on the others, but I think we'll have to stop. I don't think we'll have time to do minus pi thirds. So we'll start with that next time. Okay, we'll start with the D part, minus pi thirds minus pi thirds. Let's see how many homework exercises we can do. Do either 5 or 7, they're both at Calc Chat. Do 9 or 11, they're both at Calc Chat. Do any of the odds, 13 through 21, they're all at Calc Chat. I think you can do any of the odds 23 to 29, they're all at Calc Chat. Now if you can't do the negatives, we haven't done the negative yet, if you can't do those, just wait and do those next time. Okay, and we'll stop right there. Okay, so you can stop earlier if you don't want to do with those negatives. They're pretty easy, but if you don't want to mess with them, you don't have to. But you can do any of those positive ones that are there. All right, any questions on anything we've done? What's this? Okay, thank you so much. Thank you for reminding me. Boy, this is a great class, I can tell. So let me go on and, yes, let me get the question in first. Those homework exercises, all on page 275. 4.2. Okay, good deal. Any other questions before I stop the recording?
Where do we submit those to?
Okay. Remember, I only need one a week. But if you have problems with more than one, get them all to me, okay? But you can either, okay, if you do them on pencil and paper or whatever, if you can scan them, send them to me as a PDF. If you type them up in a Word file, you can send them to me as a Word file. If you do it, take a picture with your iPhone or with your smartphone, be sure it's in JPEG or some real common type thing. I had a student in one of my classes, I don't remember which one, send me something in a HEPIP or something like that file. My computer would not read it. So I'm guessing either she was going from a Mac or some product like that, or she was using some sort of fancier thing that my computer wouldn't handle. So I know it can do JPEGs, I know it can do PDFs, I know it can do doc files, Word files. So in whichever format you've got, you can either put it as an attachment to an email and send it to me. You can put it as an attachment to a Word message, a Blackboard message and send it to me. Either one. I don't care. Just get me just one homework exercise, unless you're having trouble with more than one. Then get me as many as you're having trouble with, and we'll try to work through those. And I'll probably show those in class the next time. I won't say who's having problems. The odds are if one of you is having problems, there's probably a good number of the others that are also having problems. Okay? Does that answer your question?
Yes, thank you.
All righty, good deal. Any other things before I stop the recording? All right, I'm going to, yes.
You said something about like the problems, like you can check it from like a website. Can you repeat that website, or was it something?
Okay. I'll show it to you, in fact. The homework exercises, you see at the top of the page there's 4.2 exercises. Look right next to that. See calcchat.com for worked out solutions for the odd number exercises. There they are. But some of these, like you see that group right there, see number, I can't read it, is that 15? The first one listed there, that one's in red. And you see that QR code above it? You can go to calcview.com. Now, if you want to see that title, here it is, calcview.com. There you see not just worked out solutions, interactive solutions to those problems. So you can actually interact with that one. So those are the two absolutely free websites, in addition to larsonprecalculus.com, which is where some of the examples are and all the checkpoints are. That's larsonprecalculus.com. I'll show you that one here. See, there's that checkpoint. See, I can't read it because it's too small. audio video solutions to in English and Spanish available at larsonprecalculus.com, and that's on the back cover of your book too. larsonprecalculus.com. Where is it? Yeah, there it is. larsonprecalculus.com, calcchat.com, calcview.com. Okay, all three of them free websites, and every homework exercise is at CalcChat. Some of them, a few selected ones, are at CalcView. All of the checkpoints are at larsonprecalculus.com, and some of the examples are at larsonprecalculus.com. That answer enough of your questions? Any others? Okay. Okay, any others? Good questions. Excellent questions. Okay, I'm going to end recording now then.